Campus fabrics are all about an agile, resilient and scalable network that utilizes EVPN routing and VxLAN tunneling. But deploying a campus fabric shouldn't be a headache, and in this video I will show you how to deploy a campus fabric multi-homing topology on Juniper Networks Mist solution. Hey everybody and welcome back. If it's your first time here, welcome to this channel. I'm David Townsend. This is the Net Academy where we are learning networks together. And on this video, on this part, what I'm going to be going through is how to deploy a campus fabric topology on Juniper Networks Mist solution. Now, if you don't know what Mist is, if you don't know where it is, just in a very quick summary, what it is it's a cloud-based microservices solution that utilizes several different forms of artificial intelligence for enterprise networks on the wireless, Wi-Fi, switching, wired network, and also on the WAN, SD-WAN, plus there's network access control, NAC, IoT assurance, plus so much more. Really, if you want more details on what Mist is, please check out this link. It's a video that I've done which describes it all basically. But that's not the intent, that's not the purpose of this video, is to show you how quick and easy it is to deploy campus fabric on Mist. And I'm doing this because for the first time last week I had to do so for something at work. I won't say any more than that obviously, but I was so impressed with how easy it is on Mist that I just simply had to do this video. And there are different types of topologies in a campus fabric, but all of them utilize EVPN. All of them utilize VXLAN tunneling. And they bring so many benefits to the table, such as aliasing and mass MAC withdrawal and allowing layer 2 connectivity over a layer 3 network. And more campus fabrics are looking at deploying EVPN routing and VXLAN tunneling because of all those benefits, plus so much more. But honestly, EVPN might be new to some enterprises. It might be a little bit scary. But deploying it, as I said, shouldn't be during the intro. And that's what this video is intended to do, to show you how quick and easy it is to do so on the Mist solution. But enough of me talking. Let's first start off in the lab and show you the topology so you understand the setup, and then we'll go on from there. And here is the lab setup for this video, and I just want to show you this so you understand the setup before going any further, because if I don't show you this and then go straight into configuring the campus fabric, you won't really know what the setup is. You won't know what it actually looks like. So first and foremost, all of these are running the vJunos or VEX software. These aren't physical switches, they're virtual images that I've installed into my EVNG environment on my bare metal server. Now, looking at the network, what there are, of course, is there's core 1 and core 2, as you could see, and there's also 3 access layer switches: access layer 1, access layer 2, and access 3. Now, in terms of connectivity, everything from the core down to the access layer, or from the access layer up to the core, is running layer 2. So basically, with these different VLANs, and I'll come on to that in just a second, all of them are being trunked from those access layer switches up to the core. And it's only between core 1 and core 2 where we've got layer 3. Everything else is layer 2. Layer 2 basically everywhere. And when it comes to layer 3, there's two important points just to initially make you aware. First and foremost is, for layer 3, there is the concept of the underlay. You need an underlay IGP routing protocol to allow connectivity between core 1 and core 2. And really within this underlay, what you would do via Mist, and it does this for you automatically of course, is it's going to advertise its loopback 0.0 address into the underlay. That then paves the way for the second part, which is the overlay. Now in the overlay, the core 1 and core 2 build the adjacency using that loopback 0, and that's why it's advertised in that first step on the underlay. And And you might be wondering, what are we using as a routing protocol? And for both the underlay and for both the overlay, it is EBGP, or External Border Gateway Protocol. And the reason why Mist is using this for both the underlay and for the overlay is because it's so stinking scalable at the end of the day. It's so powerful. You've got all the path attributes. Every core device in this particular topology will have a different autonomous system number. You've got the AS path, you could do routing policies, and it's just very powerful. It's what makes the internet work. And the reason why we don't use IBGP is because with IBGP, you've got to take into account maybe something like route reflectors just to bounce routes and reflect routes from each other. It's more a configuration, and IBGP does have some limitations. Not going to go into that, but just know for the underlay and the overlay, it is EBGP that Mist is actually using. And I just mentioned as well VLAN. So as you can see, user 1 and user 2, they are in the blue VLAN if you want to think of it like that. But really they are both in VLAN 10, or the name that we'll give in the configuration V10. User 3 and user 4, they are both in VLAN 20. Now this is important because obviously the access layer switches need to be configured for this to allow access. So these would be access interfaces of those hosts into the network, and then they just trunk, as I said, everything up to those core devices, which are basically the gateways. And of course we'll come on to this configuration. But when it comes to VxLAN, VxLAN has got this concept, this terminology of VNI, or Virtual Network Identifier. That's basically when you have a VLAN and its ID mapped to a particular VNI. You don't need to configure this in Mist. Mist just does this for you. It just needs to know what your intent is on the network, and it will take that intent and deploy it for you automatically and seamlessly, of course, onto the network. But I just wanted to show you very quickly what this is, what the setup is, and where really the layer 3 routing is taking place. So really a lot of the configuration is going to be pushed down onto core 1 and core 2, because the access layer switches, they're just doing layer 2 trunking up to the core. Between the core is where that EVPN on the overlay really comes into it, as well as VXLAN tunneling. And the final point on the setup is, if we look at it from access layer 1, everything in terms of the interfaces, it will see as an aggregated Ethernet, or AE bundle. But from the core switches, what they see this as an Ethernet segment identifier, or ESI. There are obviously differences between the two, and if you don't know what EVPN is, just please check out this link. It's all described there in terms of the key concepts to actually understand. But ESI is basically a 10 hex value that identifies uniquely a single homed or a multi-homed tenant. Now really it's the multi-homed part, because this is a multi-home topology, and this is important because say the link between access layer 1 and core 1 goes down, so this link here goes down. What would happen using EVPN is core 1 would advertise over to core 2 that I've lost connectivity to access layer 1, and I'm now withdrawing all of these addresses, and just core 2 just knows to get to access layer 2 via its down link here, and they're all identified. So this would be an ESI, and it's a bit difficult to draw. This would be an ESI as well. It just uniquely identifies that throughout the entire network. And let's also talk about that key concept that I just mentioned as well, gateways. So the gateways will be on the core devices, core 1 and core 2. Now for both of these, they will share, and I'll show this, a virtual IP address. And this is basically what's referred to as an anycast gateway, i.e. they both have that same IP address. It is consistent across those layer 3 gateways. So if user 1 was to move all the way across the network to here and then connect into access layer 3, the core devices would then see, user 1 is no longer connected to access layer 1, it's now connected to access layer 3. And additionally, coming back to this Anycast gateway, when host 1 moved over to here, what it would of course do is DHCP. It would get a DHCP assigned address, and within there would be that gateway IP address. Now that gateway is basically this here. So the point is, doesn't matter where those users actually roam to, it is going to have the same gateway. It doesn't have to opt for a new gateway. It's just provided to it, and that's less network configuration, and it's improved network connectivity in terms of just getting connectivity to the network and all of its resources. So now let's move on to configuring that campus fabric in Mist. But before I do so, I just want to show you just very quickly Core 1's configuration, just so you can see a before and after. So if I just quickly do a show configuration, you can see, yeah, there's obviously some configuration here. It's already been onboarded onto the Mist, but there's really nothing here for EVPN. And let's go right to the bottom. There's nothing really fancy in here, is there? Note the only VLANs is for the default VLAN, VLAN 1, But honestly, there's not much here. This is going to change. And so here we are on my Mist.org. You can see, hey, here's my name there. So it's David Townsend, of course. And to create that campus fabric, you do so under organization and then select the campus fabric option within that. And to create the campus fabric, guess what? You select the campus fabric icon here. And note the different steps. First one, you should define the topology. Step 2, you define what nodes you want to participate in this campus fabric. Here is really where we start defining the VLANs, the networks, and maybe VRFs. We'll come on to that in just a few minutes time, of course. Step 4, you define what are the ports, the downlink and the uplink ports. And finally, step 5, you confirm the topology before actually deploying it. So really 4 steps, 5th step being confirm, start to finish, very straightforward. But as you can see here, there's 3 different types of topologies. The one we're going to be deploying is, of course, this topology here. Multi-homing using ESI lag with layer 3 at that collapsed core layer. But then you've also got core distribution, which is where you could have the layer 3 gateway at the core or maybe at the edge, which would be an ERB model. Or there's an IP closet where you get layer 3 EVPN all the way from the core all the way down to the access layer switches to allow for micro segmentation, really. So 3 different topologies, but as I said, we're really going to be doing this top topology here. So first things first, let's just give it a name, shall we? So let's just call it Campus Fabric, CF for short, collapsed core, because really this is what it is at the end of the day. It's a collapsed core where that core layer switch has collapsed down onto that distribution layer switch. Now, as I mentioned before, there is the underlay using eBGP and there is the overlay using eBGP, and that's why you're seeing AS here and AS here, because we need to tell Mist what is that autonomous system number, or that range, that AS number for both the underlay and for the overlay. And when you define that number, Mist is just automatically going to take that name, take that range, and automatically assign that out onto those switches that we define in the nodes in the next step. But what you could see here as well, you could do so with IPv4 or IPv6 as the underlay. But what is this subnet here? What is all of this actually about? Well, coming back to the EVE-NG environment, what that subnet is when you define the subnet, and what I'm going to do is I'm going to define 170.10.20.0/24. What Mist is going to do is it's going to take this subnet and it's going to assign those layer 3 interfaces with an IP address from this subnet. Where are those layer 3 interfaces? Well, remember that is only between core 1 and core 2. Everything from core down to access and vice versa is layer 2. It's trunking basically everywhere. So we only need 1, 2, 3, 4 IP addresses out of this /24 subnet. Mist is just automatically going to give an IP address to those 4 interfaces. And the benefit of having a /24, and is a little bit of my default behavior, is if you were to extend this out in the future and include a 3rd core, obviously a /24 is more than large enough to accommodate, even with 2 extra interfaces, another 2 IP addresses, or technically 4 IP addresses, to come out of this subnet. So that is what is meant by the subnet. So back on Mist, it's now give it the subnet 170.10.20.0/24. And again, Mist is just going to take an IP address, 4 IP addresses from that pool, and when we deploy it, boom, just configure those layer 3 interfaces between core 1 and core 2 to have one of those IP addresses. And again, what is this auto router subnet / the loopback interface? What is that about? Well, coming back to EVNG environment once again, we know, as I just described, we've got layer 3 between core 1 and core 2. We defined just now the subnet between these core devices for those interfaces. But what is this router ID? What is that? And the subnet? Well, again, we define a subnet, and as I'm going to do 1.1.1.0/24. And guess what? Mist will just take a router ID from this subnet and give it to core 1 and to core 2. So core 1 might come out like something like 1.1.1.1, and core 2 might have 1.1.1.2, just for example. Honestly, I do not know, because Mist just does this for you. But you need this. Every layer 3 device which is doing OSPF, ISIS, eBGP, iBGP, doesn't matter. It needs a router ID. And that's what you're defining here, is what is that subnet that Mist can pick from and assign to those devices that are participating in this EVPN domain. And back on Mist, let's define that now. So let's do 1.1.1.0/24. That is the first step done. I can now push continue, and I'm now on the second part, nodes. And guess what? All we need to do for the collapsed core and for the access layer is define what switches we want to participate. So obviously we want core 1 and core 2 at the collapsed core layer, and we need the access layer switches 1 plus 2 plus 3, those 3 access layer switches, to be in this topology. How do we do that? Hopefully you can see this plus icon just here. That's it. We just hit that plus icon, and as you can see, we've got core 1, core 2. So I'm going to select these, select those 2. That's it. Core 1 and core 2 will participate in this campus fabric, obviously once I deploy it. And we do the same for access layer. So I'm going to select access 1, access 2, access 3. Note the explanation mark behind those core devices. It's saying, Mist is saying you can't use these core devices because they're already in use. So let's select these. Step 2, done. How quick and easy is that? And the third step here is really where you get into more of the network configuration, as obviously the term network settings really implies. Now networks here, this is really the Mist terminology for VLANs. So here you can actually create your own VLANs with their own subnet, VLAN ID and VLAN identifier, etc. Or you can add an existing VLAN, an existing network that's been configured at the site or at the org level via one of those templates. But what I'm going to do is I'm actually going to import some existing ones and obviously show you the configuration. So let's do add existing network, and you can see VLAN 10 and VLAN 20. And this restricted access, that's just default. I'm not going to do that. But what I can do is just select these or create new ones, of course. Select the tick mark just there, and you can see they've now become there. But note, a virtual gateway is required. That virtual gateway is that Anycast address. So if I select VLAN 10, we can see the ID here, we can see the name, V10. We can see the subnet that it's going to be operating in, i.e. 192.168.10.0/24. Don't need to worry about IPv6, but here is that Anycast gateway that will be shared for VLAN 10 on both core 1 and on core 2. And again, Mist just deploys this for you. And what I'm going to do is I'm going to have this as a 192.168.10.254. And that's it. That is the gateway, that Anycast distributed gateway for VLAN 10. I also need to do the same for VLAN 20. So now I'm going to do 192.168.20.0/24. And there we go there. I had made a little bit of a typo there. We're all human, we make mistakes. But 192.168.20.254 for VLAN 20. And that's it. That is my networks defined with their virtual gateway. But what is this other IP configuration? The best way to describe this is it's the IRB interface and the IP address assigned to that. So when we're talking about a layer 3 gateway, a layer 3 gateway will have an IRB interface. So say, for example, this was IRB.10 for VLAN 10. But underneath the IRB interface, you'd then have that virtual IP address that we just defined in this step here. To take it one step further, just to give you pretty much the Junos configuration, this would look like set interfaces IRB.10 family inet address, and then we define the address of that IRB interface. So if we look at it for VLAN 10, that could be 192.168.10.2, just for example. And we're also going to do the same for .20, but here you'd have something like 192.168.20.2. Basically, that IRB interface needs an IP address, and once you've defined the IP address, you can then define that virtual IP. You can't have one without the other. So we've got to do this other IP configuration. So let's just do that now. So under core 1, so this is for the core layer device 1, we've got VLAN 10, VLAN 20, and you can already see for VLAN 10, it's got 192.168.10.2, and for VLAN 20 on core 1, 192.168.20.2. And just to look at it from core 2's perspective, we've got VLAN 10, 192.168.10.3, and for VLAN 20, 192.168.20.3. And that's really it. It's not much more you need to do. But what is this VRF? Well, I'm sure we all know what VRF stands for, virtual routing and forwarding. But let's look at it from a campus fabric use case. Why would you want to enable a VRF? Well, you are, of course, going to have, or maybe, I don't want to assume, maybe you've got guests coming onto your university, coming into your hospital, coming into your distribution center from a retail perspective, whatever it may be. You've got guests coming in who may be connecting directly via an Ethernet cable into your wire network, or maybe they're connecting to that Wi-Fi network. And at the same time, you've got corporate users as well with their corporate devices and laptops, mobile phones, etc. With a VRF, you can assign these different types of users into different VRFs. So we could have a VRF for guests, and we could also have a VRF for corporate devices. And as such, will they have connectivity to and from each other? The answer is no, they will not have any connectivity to and from each other because they're in different VRFs. You can, of course, give them connectivity via configuration, but for that you'd need like an MX router or a firewall appliance if you want to do security inspection, especially for guests that are coming to your network, but that falls outside of the campus fabric. But that is typically why, as a good example, why you'd want to have different VRFs. You can have everything in one VRF, that's what I'm going to do, or you could segment your traffic away from each other for isolation and, of course, segmentation. So let's enable the VRF, and let's actually add that VRF instance. Now I'm just going to give it a name. I'm just going to call this VRF-CC, and it's saying, yeah, a network is required, and I'm just going to add my two networks, VLAN 10, VLAN 20 into the same VRF. And note here, extra routes. What is this extra routes? Well, as I just said, if you wanted to allow interoperability between different VRFs, or maybe if you wanted to forward this traffic to a firewall, deep layer application inspection device, not my area to be honest, you could add in a route here. It's not something that's in my topology, but you could say that all of this traffic for this I want you to go via this IP address for this particular VLAN, for whatever it is. I'm just making something up here. But you get the idea. It allows you to add in a particular route, such as a default route or maybe a more specific route via an external device. But really, that is my VRF actually defined. So let's hit save on that. I'm not doing any DHCP relay, so that is just disabled. And the next part is the core access port configuration in terms of that Ethernet segment identifier, that ESI lag, that big benefit that EVPN brings to the table in terms of multi-homing and fast convergence. So let's just give it a name. I'm just going to call it ESI lag or ESI because the name's already in use by another CF I've got set up. And just to show you, remove those, you say what networks do you want to trunk over your ESI. So I want to trunk VLAN 10 and VLAN 20. Let's bring this back to the EVNG. So just as a quick refresher, as I said, from access layer 1's perspective, it sees both of these links as an aggregated Ethernet, and it actually believes it's connected to the same switch, the same chassis, when in reality, as we know, it's connected to two different core devices, core 1 and core 2. And that is because they have an ESI defined, and within that, they are, via LACP, they're changing the system ID so that core 1 and core 2 have that same system identifier. And thus, access layer 1, it's tricked, it's fooled into thinking it's connected to the same upstream device. Really, that's nothing new. But as I said before, if this link goes down, core 1 will advertise over to core 2 that you cannot get to access layer 1 anymore through me. And he will also advertise over that all of those MAC addresses that you learned previously connected to access layer 1. So say there's a server down here and you had hundreds of virtual machines running here, it would then advertise over to core 2 saying you can't get to these MAC addresses through me anymore. Very, very scalable, very fast, very efficient for today's modern networks that really need improved network resilience and connectivity. And that's basically what we're doing here. Is you're saying what networks, what VLANs do you want to trunk between that core and access layer? And you can do some advanced features such as the speed, and do you want to limit the amount of MACs that's like that moving, MTU, etc, etc. I'm not going to do that. But that is the third step, network settings. The fourth step, we're actually going to define the ports. So I'm going to hit continue. And this is what this looks like. And I just want to go back to EVNG to show you the port configuration, the ports that we're actually using. So you can actually see from core 1 and core 2, they're using the same interfaces. So we've got Gigi 000 and Gigi 001, Gigi 000 and Gigi 001 to and from each other between core 1 and of course core 2. Now we need to define that, and we will define that in the setup. Mist needs to know what interfaces to use between core 1 and core 2. But it also needs to know the downlink interfaces. So we've got Gigi 001, 2 and 3 to access layer 1, access 2 and access 3 respectively. And again in Mist, you're going to tell Mist in this step what interfaces to use to get to those downstream devices. But you also have to, and you see this only takes a minute, you have to define for those access layer switches what are their uplink interfaces. So we can see we're using Gigi 1, Gigi 2, Gigi 1, Gigi 2, Gigi 1, Gigi 2 to get to core 1 and core 2 respectively. So you could see there's a common consistent approach there. That's why I showed that, because if I come back over to the Mist campus fabric setup, under the core switches for core 1, we now define those ports. So recall Gigi 0 is a Gigi port to the collapsed core, and this is going to be our link 1. And we're also using port 4, which is also Gigi linking to our collapsed core. This will be our link 2. If I select core 2, we can also define exactly the same. So port 0 Gigi link to core 1, link 1, and port 4 Gigi to core 1, and that's link 2. And you can actually see that the attributes here, keep an eye here, they're actually changing. So all of my links to the cores are done, but we've got no interfaces assigned to the access layers to the downlink. So if I come back to core 1, we've got port 1, 2 and 3 going to access layer switches 1, 2, 3 respectively. So let's say port 1 link to access, and this is access 1. Port 2 link to access 2, and port 3 link to access 3. That's it, done. Core 2 exactly the same. Port 1 link to access 1, port 2 link to access, you get the idea, access 2, and finally port 3 link to access 3. Done. That is the core layer switches. Now knowing what interfaces to use and assign as the downlinks, the uplinks, and to use in an ESI lag bundle. But we also have to do almost the same on the access layer switches. But honestly, it's not as much. So if I select access layer 3, we just define port 1 and port 2. So this is a gigi port, port 2, this is a gigi port, access layer 1, this is a gigi port, port 2, this is a gigi port, and access 2, this is also gigi port, and port 2 is a gigi port. That's it. Really straightforward. And now let's hit continue. And finally, let's just confirm our configuration. So if I select core 1, what you can see on the right hand side is the system's MAC address. It's running vJonas, as I said. Good news is it's connected, otherwise this wouldn't work. This will be the router ID that it will get. So under the topology setting, remember we configured that router subnet. So Mist is already telling us that core 1 is going to get this router ID just automatically. And we can see the IP addresses that we configured under network settings under the other IP configuration. And we can see the ports to get to core 2, and down here the interfaces to get to those access layer switches. It's just a quick verification step before you deploy this. But what I'm going to do is I'm just going to say apply the changes, and it's going to just say, yep, I'm going to push this from the Mist cloud onto the switches. Let's confirm that, and let's come back in a few minutes time and let's verify this configuration. So it's been more than enough minutes now. Let's actually have a look and validate that this campus fabric configuration for a multi-homed EVPN network has been deployed from the Mist network onto my lab here. So let's select CFCC, campus fabric, collapsed core. This isn't actually where I'm going to do most of the verification, just so you know, but there is one area that I particularly like in here. And so if I just select, for example, core 1, then you can see right at the bottom the very important information. Now note here the underlay. As I said, there's actually going to be two parts of that IP network. There's going to be the underlay and the overlay. Why are you seeing two underlays? That's because there's two connections between core 1 and core 2. So two connections in total over two different links, hence you've got two underlay here's. And what you can see is the IP address. Note that these were taken from that subnet, from that configuration that we configured in one of those initial steps. We can also see the neighbor autonomous system and the local autonomous system. And we can also see that there's been some routes and bytes that have been bouncing back and forth. But the big thing to look at is actually right here. Of course, this is very good, green connected. It's always good to see green on anything. But here is the established state. That is the BGP terminology for that peering between core 1 and core 2 has been, guess what, established. The peering is up. They're exchanging routes. They're learning who's connected to them. So initially, this is looking absolutely really good news. But let's go a little bit further. And here are actually my five switches, core 1, core 2, I don't need to look at the access layer switches, only core 1 or core 2. Only one of them, because don't forget that's where the layer 3 gateway actually is. That's where all the IP routing is taking place. So let's look at core 1. And of course what you could see, 100% configuration success. That's a very good thing. Oh, but what can you see here in terms of statistics for the IP addresses? Well, first off, what's this here? This is basically my management interface. This is what's being used at the FXP0 interface to get to the internet. So let's not worry about that. But what you can see here is that router ID. That was again configured in a subnet. We gave a range, didn't we, of something like 1.1.1.0/24. And that means that Mist just automatically gave the 1.1.1.2 the loopback 0 as well. It's going to share the same. Root ID is going to be the same as the loopback 0 address. Has automatically been populated by Mist. And then right down here, we've got those point-to-point interfaces between core 1 and core 2. So we can actually see the subnet information, the IP addressing for that subnet on those interfaces. And right here are those IRB interfaces, the actual IP address that was configured under other IP configuration. Just all showing there, all green, very good. But note here as well, it's also got that additional IP configuration. So for VLAN 10 and for VLAN 20 with those IDs, it's got this IP address and it's got this IP address. What we can also see under the port configuration is that the GigE00 and the GigE004, don't forget they were going to core 2, weren't they? Those two interfaces. And Mist has automatically created an EVPN uplink and an EVPN downlink to core 2. And in terms of these interfaces here, these were going to our access layer switches 1, 2, 3 via an ESI. Mist has automatically created that port configuration for these interfaces facing access layer switch 1, 2 and 3 to have an ESI value. What I can also do is I can just go to the top and go into switch insights into core 1, and we can actually see all the switch events here. So we can actually see, if I just scroll down and down, we could see that it was configured. There's a spanning tree topology change configured by user, and we had the AE0, 1 and 2, that's AE bundles. And what we've then got is our BGP being actually established, as you can see it, over those GigE000 or that GigE004 port. So very good news, of course. And what you can also see is right here, as we showed before, everything is in the established state. We can also see some MAC addresses. We could see with the ARC tables being populated, we've got some root summaries, and we can even go into that EVPN database, so you can query that EVPN database on that campus fabric switch from Mist. Let's just have a quick look at that. So if I just select search entries here, I'm not going to do any fancy MAC address. So I'm just going to hit search, and you can see it's now querying for all those MAC addresses. EVPN is really concerned about MAC addresses and optionally IP addresses in terms of advertisement, but we can see the MAC address of all those devices and those end clients that have been learned. So what we can see here is the MAC address for this IP address. Now that is the IRB interface on core 2, has been learned over this particular ESI with this VNI, this VxLAN or virtual network identifier 10,010. So that's very good information just to query just initially. But let's actually just close this, and let's go back to the EVNG, and let's go back to core 1. And what I'm going to do is I'm going to write show configuration, display set, no comments, display inheritance, no comments, there we go. And I'm just going to do no more so I don't have to keep hitting space, and look at all this configuration. So what you can see is note it's just created the underlay. It gave me an autonomous system for the underlay. It's saying I can use multi-paths and through multiple autonomous system numbers. It's told me the neighbor and the peer autonomous system. We've also then got the family EVPN signaling. If I scroll back up, just note all of this rich information. So here is my VRF collapsed core with a particular route target and label and routing options, policy statements as well, just everything. The IRB interfaces and the ability to define for that IRB virtual IP to accept pings, and the IP addresses, note the virtual gateway IP address and the IRB INET address itself. You can see there's a lot, and even the ESI values here just automatically generated by Mist. The real question though is, do we have connectivity from hosts? So if I go on user 1, and let's just give this a try, let's ping 192.168.10.11, which is user 2's IP address, and we have connectivity. Do we have connectivity to 192.168.20.10? And we do. It worried me there just for a second, but it was just the first initial ping. So we could see host 1, user 1 can ping user 3 from VLAN 10 to VLAN 20, from one VNI to another VNI. And let's just test it from user 3's perspective. So let's now ping user 4 from user 3. So let's do 192.168.20.11. We have connectivity, and can that ping user 2, which is 192.168.10.11. And there you go. We have just verified that we've got round trip connectivity from hosts in different VLANs, in different subnets, and those packets are just being trunked up to the core, where it's going from one VNI to another VNI, trunked back down, and the connectivity, the ping response. And so there we go, everybody. I hope you found that useful. I hope you found that informative. That was actually a very quick video on how to configure a campus fabric multi-homing topology on Mist. And hopefully you could take away from that just how quick and easy it actually is to do. Now, EVPN is a complex protocol. I'm not going to say it's easy. It's really not at the end of the day, but it's designed to do a lot in terms of advertisements and ESIs and load balancing and DCI interconnectivity. There's a lot you get from the EVPN world. But deploying it in an enterprise network really shouldn't be difficult. And that's why I've done this video, to show that using Mist is actually very straightforward, very easy, and very scalable to do. So any questions or comments, please let me know down in the comments box. I love hearing from you all. Other than that, thanks for watching and goodbye.